Hi class, this is Dr. Jones, and this is my video that I wanted to do showing you how to graph the data for this week's experiment. So this is the data that's been submitted by one of the students. It has the student used two radii, one of 41 centimeters or 0.41 meters, and one of 21 centimeters or 0.21 meters, okay? And they actually collected data for each of the masses that I talked about with the radius of 0.41 and a radius of 0.21. Okay, and so here is the data that they have for their three trials of 20 revolutions using the two radii. So the first thing that we need is the average. So I'm going to put the at average, as we talked about before, open parentheses, and I'm going to select all three trials, close parentheses, hit enter, and it gives me my average. If I click on that cell, I go to the black square, I click and hold down, right click and hold down with the plus and drag it down, and it gives me the data, the average for each of these sets of data. And the easiest thing to do here is, since it's all selected, I'm just going to go over here and I'm going to copy it. I'm going to go down here and I'm going to paste it, and it gives me the averages for that data as well. So now I have the average, and that's for 20 revolutions or 20 turns. So next I need it for one revolution, and so I need to take the average and divide it by 20. So I put equal sign, I click on the average, and I divide it by 20, okay, and that gives me the period of one revolution of one turn. So again, I'm going to click on the black square, it becomes a plus, left click, drag, okay, I'm going to copy, go down here, paste, and so now I have that data, okay, for this set of data. Now I gave you an equation for the velocity, and that equation was that the velocity was equal to 2 times pi times the radius divided by the period. So I need an equation, so I'm going to put an equal 2 times pi, which is 3.14159, okay, times the radius, okay, and the radius is 0.41 in this case, so that's 0.41 divided by the period. And so I'm going to click on the period here and hit enter, and it gives me the velocity, okay, and so I am going to right click and drag, copy, go here, paste, okay. So now I have the velocities for both sets of data. Now I need the velocity square, so I'm going to click here. Again, I need an equation, so I'm going to put equal. I'm going to click on the velocity, use a caret, which tells me I need a power and a 2. And that squares that, so that's the square of the velocity. Right click, drag, copy, click here, paste. So now I have my velocity. Alright, so now I have the data, okay, that I have the velocity squared. And we want a graph for the force on the x and the velocity squared on the y. So what I'm going to do is I'm going to go ahead and copy my velocity squared because I already have that. And so if I go to the first set of data, I'm going to copy this, and here on the y-axis for velocity squared, I am going to paste this as values. I'm going to go here for the second radius. I'm going to copy it. I'm going to go here and I'm going to paste this as, oh, I'm sorry, I need to paste this as values. So I'm going to go here and I'll paste this as values. Okay, I clicked on the wrong paste this as values. So now I have my velocity squares. Now I need to figure out my force. And force, remember, is the mass in kilograms times the acceleration due to gravity, which is 9.8 meters per second squared. So I'm going to go here, okay, and I'm going to say that the force is equal to the mass, and I need it in kilograms, so I'm going to divide it by 1,000 times 9.8. And I selected the mass from the 0.21 meter radius. It doesn't matter because the masses should be the same. And so I am going to copy this all the way down. Okay. Then I am going to copy. I'm going to go here and I'm going to paste as values because they should be identical. And so now I have my X and Y axis data. And so I'm ready to graph. Okay. Now, so to graph, I want to put force on the x-axis and velocity squared on the y. So what I'm going to do is I am going to insert an xy scatter. Okay. I am going to select my data. So I'm going to remove this and add new data. And for the x, I am going to highlight the force values. For the y, I'm going to highlight the, move this over, velocity squared values. I'm going to hit enter and click OK. Click OK. And this should be my data. So I look at my numbers and those look correct for my x-axis. I look at my numbers here between 5 and 27. That looks correct for my y-axis. It looks pretty linear. I'm going to right click on one of the dots, add a trend line. It should be linear equation and r squared on chart. I close it. If I look at that, that is a very, very good data. R squared is close to 1. So now I'm ready to go to my layout. Okay, chart title is going to be the dependence of velocity squared on hanging force. Okay. And I am going to add my axis titles. This is the hanging force. And that is in newtons. Okay. I'm going to click here. Vertical. I like when it's rotated. So I'm going to click here. This is going to be velocity squared. And actually you can do velocity with the 2 because we remember how to do that. And that's going to be in meters squared over second squared. And what I can do is I can highlight my 2. And when I highlight my 2, of course, go home, go to font, make it a superscript, highlight my 2. I believe I hit subscript on that, so I'm going to correct it. Go to font, superscript. I'm going to correct this one. You can also right click, that's what I'm doing here, and go to font. And that should be superscript, not subscript. And I can do it for the 2 here. So we'll right click, font, superscript, and I do OK. And I'm actually going to I'm going to move this location. So move the chart to a new sheet. And so that's my data, and it looks good. Okay, I'm very happy with that. Now if I look at this, my slope is 108.53. Okay, that's what the slope that I have. So if I go here to the data sheet, okay, my slope is 108.53. Okay, and I tell you that I want you to take the ratio of the radius divided by the mass. Now it's important to realize that we have to put our mass in kilograms because we converted it to kilograms to do the force. So the radius divided by the mass is going to be equal to 0.41 divided by open parentheses. We put a 5 gram mass, so that's going to be 5 divided by 1,000. Okay. Oh, I think I may have made a mistake here. Let me check this. Oh, I've divided by 100 and not 1,000. That's my mistake. So that should be divided by 1,000. Okay, and so what that does is it gives us a value of 82. And we're supposed to compare that value to the slope. And if I compare that value to the slope, the percent error, okay, if I do the percent error, it's going to be, open parentheses, the larger of the two, which is 108.53 minus 82, okay, divided by 82 times 100. Okay, so that's 32% error. That's quite a bit of error. And what I would do is I would do the same thing for my values here. Okay, so I would graph these set of values. I would take the slope, I would take the radius, and I misspelled radius here, so I'm going to correct that. Okay, divided by the mass, and then get the percent error. Okay, so that's basically how we actually graph our data for this experiment. And so I hope that this has been helpful, and let me know if you have any questions.